We'll start. In theory, that'll work. Alrighty. So we are going to return to this. Hey folks, sorry about the discontinuity. My DSL box crashed. Every now and then it does that. Not very often, I'll say, but if there's any kind of hiccup, then the DSL connection will drop and the router has to reboot itself, so that's what happened. If folks want to rejoin me, that's fine. We're going to be finishing this up. Yep, Ro and Jess are back. Alrighty. I think we're back in the saddle again. Let me juggle my windows and be ready to go. So here we are. Everybody who got bumped off, that's because my DSL crashed, which doesn't happen often, but when something goes wrong with the with Silvernet and the DSL lines go down, then my router goes dead and reboots itself, and that's what just happened. So we don't get to continue the previous stream because it took too long crashing to just reconnect, but we'll just sort of double stream it, I guess. And here's where we left off. I just added these. They're the same as what I already had here, but instead there's a capital A and a capital B in them because I want to do interpolating. So first of all, we'll build and see that we can do this. And we can. And second of all, we're going to go in and make it, we're going to go in and make it go. Excuse me. So all of this stuff needs to get updated. Including everything inside the algorithms. I'll do that in a moment. I'll probably scan upwards for those. There's one. There's another. Wait, did I want A? No, I don't think I did. I wanted to define B, not A. What am I doing? We'll fix. We will fix. My fingers get confused sometimes doing this stuff. I'm good at turning these things into like little repetitive behaviors, but if I get mixed up, then it'll become a problem. So I don't want it to become a problem, so let's not have a problem. Sometimes I think that in doing this stuff I sound like the biggest autistic nerd. Oh well, that's not so far off. But I'm doing stuff and it helps other people, and that's the important part. So now we have this defined as AB. You know why? Because my intention is to make it so that when you're instantiating these things, oh, I see a potential problem though. But I think I see how to fix it too. I'm going to check one of these whether it's 0, because some of these numbers can never be 0. And if it's 0, it will crash. And I can check to see if it's 0, and if it's 0, I know that I need to update all of these to start out being the preset. They can only chase legal values if they're already legal values, and they instantiate as zeros. So what we're going to do, we've got all of this. We get to choose each kind of filter. And then we can check one of them. Oh, no capitals, please. Let's see which one. Good. So K is frequency. Norm is reso. You can see why that can't be 0, because that's a divide. And norm starts out as being a 1. K is tan m pi times biquad, but this is gonna end up being something that is not 0. So let's just assume that my biquad A coefficient, like this biquad A be 0, no matter what kind of calculation I'm doing, always has to be something that isn't 0. So if I have a 0 here, everything crashes and dies. I think probably they're all going to be like that, but let's assume this first one is like that. Then we're going to check this other thing. Equals equals for comparing stuff. Equals means I would just be assigning it to 0, and that's no good. And I can make that test. And if it is in fact a 0, I know that all the other ones are going to be zeros, and I've got to update them. Which I believe I can do by just, well, grabbing this, pasting it in, and then fiddling with it. So we don't want any of these calculations. Because we're just updating it. And we're not changing these, we're changing the other ones. So oh, hang on. Wrong. There we go. Going to have to eyeball that and make sure that it's right. Make sure that I didn't have a slip of the fingers and do something really dumb. And you see, now that these are labels, there's not as convenient a way to do a for loop in this. Aaron, what are you even missing? I've got so much. B-music, I'm not worried about that because this is just an example. This doesn't happen in the actual sample loop, and this is not what we're going to be seeing in real plugins. This is just the Biquad example. I don't have code of all of those things. And then lastly, let's even make a little note as to what the heck that is. I'm going to call that raw info, because that would essentially be not interpolated at all at this stage. Now we've got another thing. Our multiplies are going to be in long double resolution, because when we're doing that, it's always going to be, and you know something else, for Biquad Plus, let's take out the console. Let's simplify it a little bit. It's all very well, but that's a version of, that's console 5, meaning that's not the one that has the aliasing smoothed out of it. So maybe I don't want that. It's going to be a little rawer than that. This is a very simple algorithm for doing this. Now see how we've just assigned all of these to A and B versions? Well, this is not using that. Every time we go through the loop, we are remaking version B, and if we don't have zeros, we're not actually touching version A. So that follows along, and this is how it follows along, is every time we go through this loop, we're reassigning that after we've used it for something. What have we used it for? This. Oh, except hang on. No, this is not in the right place. I need to move this elsewhere. Bear with me. So this is a starter. This should compile and run and work. But this goes elsewhere. Actually, that goes here. Every time we go through this loop, this is the buffer. So what we're going to do is take the previous buffer, we have to do this here, but you know what else we're going to do is this. So every time we start a buffer, we're starting with where the control was the last time we saw it. And then if it's changed, that would make a jump to a new setting. And that's where zipper noise comes from. So if we're interpolating it, that means we start the last place, and then through the course of going through the buffer, we move to where the new control setting is. Then as we go forwards, if it stays there, that's fine. But if it's still moving around, it's always going to be chasing the setting, but it's going to be chasing at exactly the speed of what the buffer is. Therefore, it should be smoothing out stuff, but not lagging like a IIR filter on there. Because an IIR filter is going to chase so slowly, it's like, in theory, it'll never quite get there. It'll get close, but it'll never quite get there. So this will go to whatever setting we set rather rapidly while still smoothing. So we got that sorted. A0 is now equal to B0 and so on, and then we're redefining it, so now we have new settings for these and the old settings are here. And this double checks to see whether everything was 0 to start off with, because we do always need to have values in there. And so if it is 0, we sort of double check and we go in and fill it in. And now the one that we're actually using is being set to this. There is a function that we're going to use maybe it should be a small little variable. I'm thinking maybe it should be a small little variable because it's going to eat up a bunch of space. And we've got this somewhere. Where have I got this? Hang on. And sample frames is in frames to process. That changes. But I believe we've got this. Let's see if this works. We will see if that works. Those are both 32-bit integers. I want a floating point number. Therefore, what we want to do is assign the whole thing to long double, because that's what we're using, because we're doing multiplications with the long double, so it's going to have to be promoted to long double anyway. And we only need to do this once. There. Buff equals long double n sample frames divided by in frames to process. And we're not going to get too far ahead of ourselves here, but we're going to build and see if it works. It says unused variable, I knew that. I can test to make sure this is working in an amusing way too. I'll see how that works. Get back into our drums. Run it, and this should still be no change. Sure enough, we are still alive. It has not broken yet. It's also not interpolating yet, but we're kind of using the guts of the algorithm. Bit by bit, we're stepping closer to what we're actually going to need. One thing I would like to do, however, is dig up old Z low pass. Not in the Finder, though. Here. I want my frequency calculation to be more like what I had in the Z filters, because that was actually pretty good. And I'm not happy with the way that the raw Biquad is behaving. Oh, why am I looking? Oh, it doesn't matter. No, maybe it does. Let's look into the AUs, please. Cranking away. There's a fair chance that I'm going to actually successfully do this by the end of the day's streaming. Let's see how it goes. So there's the calculation for how I'm setting frequency. And here's the calculation for how I'm setting frequency here. So basically, the low pass is going from 0 to 1. and this one's going from a built-in number. So we're going to change that. So now that that one goes literally from nothing. I don't think I'm going to alter the, well, maybe I will. What do I have in resonance? Oh, nothing. I'm setting resonance to Butterworth for this one. That's fair. Not a problem. But in this one, I am intentionally sweeping this stuff along. And I set it up in such a way that it works nicely on different sample rates, and I put a lot of effort into getting that to act nice. So we're going to steal it for the Biquad and assume that we can work with that, or at least find other ways of calculating it. So instead, the frequency becomes this, because the frequency can't be more than 0.5 or less than 0.01, but we've got that kind of it stops here, and I don't think we need to have it literally cutting off at the same place, so we will take away that plus, and now this actually means something. And we'll take away this 18K and make it be 20K. 2000. There we go. Because we don't care about it being exactly the same as the Z-plane filter. We want it to kind of make sense, but we also want it to compensate for how the sample rate operates, and that's how this works. We'll double check that that worked. We'll double check it in alien kittens because we have alien kittens in 3 sample rates. Here's one of them. Okay, well that didn't go well. What's going on? NaN, what am I doing wrong? Something went wrong. That should have tested to make sure that it was something sane. Yeah, I mean, that should have worked. Let's find what happened. Something happened. If it's less than this, then it becomes 001. Let's take the old code back out of the old source. Because I want to keep that in case that wasn't the problem. No, honey, no. Super not what I had in mind. Let's try this again. This would actually work, but I'm still gonna take this. And then we comment this out and we find whether it still falls over and dies. We're technically, I think, not using overall scale here. So that might be worth paying attention to. And we're doing this, but that should have worked. So build, and let's find out whether the crash that I just had was through the thing that I just changed or something else. No, I updated it and it's still doing the same thing. If we do larger than 0, it goes to nan. It's not a number. Let's comment this out while we're at it. Like, I don't get why this would suddenly be different. This is the old code, which suggests that this is still fine. What changed? What changed up here? It should be parameters of 2. We are referring to parameter 2. We are assigning it. Oh, I know what happened. This is the thing that I did that broke it. Nothing to do with my code at all. In fact, this stuff is probably still fine. I can just put this back without even worrying about it, because that's not where the problem happened. I'll tell you where the problem happened. Look up here. This is audio unit specific. Wouldn't affect the VST or anything like that. See how it says min value 0 and max value 1? I have a flag on here that says display logarithmic. I got to take that back out. You can't have display logarithmic starting from 0. It does not work. The only way I could have the logarithmic is if min value was something and max value was something else. Otherwise, it simply does not work. And I don't need that flag because that's not like it's the resonance is using logarithmic, and that's fine too, but I just found what went wrong. And it wasn't the audio code at all. Let's build it. This time it's going to be fine. I probably have about another half an hour before I need to go and finish with the stream and go have a pee and drink too much damn coffee. But this is going well even when it's going poorly. That problem wasn't my audio code. That problem was me setting up audio units incorrectly. Subsonic 2. Bright. This is the range of behavior that I had in Z low pass, except for it goes lower. See, that's the peak. Here's the low pass. The Airwindows low pass, we can drop it lower. It's got a Q, which is resonant, so that's fine. But and now we test it to see whether it's behaving nicely on the 192K, which is going to put a little bit of strain on this laptop, but that's fine. Look at how slow it's loading. And that's acceptable. The way this is set up, it's actually cutting off at 20K, because that's the way I spelled out the Z-plane filter to work. So it's not actually functioning as a biquad that goes over the full Nyquist range, but I don't need it to be. This is closer to how stuff will be implemented in reality anyhow. And now let's dive in and pursue our further explorations. This is ready to go. Don't need to worry about Reso. Reso can be this for now, and the VST will be coded a little bit differently. We have our buffer assigning things. We have it stopping it from being 0. All of that is good. Only thing we need to do now is bring this back and a little extra fussing. See how we're assigning this directly, and this is what we started with? So when buff is starting the buffer, nsample frames is high. See, it's doing this counter so that when it's counting down from the full length, if it's larger than 0, it's still going through the buffer. So when we start, it's high. When we end, it's low. So we're going to start duplicating these, and then we'll change them. And I'm doing my usual routine of when I have mechanical stuff to do, I just do it. And we need to add these two things together. Note how this looks a little bit like what we've got down here. The thing that's wet plus the thing that's 1 minus wet. It's going to be like that, but with buff. So one of these is going to be buff, and one of these is going to be 1 minus buff. And here's our previous one. And we're starting with the previous one and moving to the new one as we go through the buffer. So we're starting with the previous one, which is A. And buff starts with nsample frames being high, and nsample frames high divided by the total number that they start with will give me a 1 as we start this loop. It'll count down from 1 to 0. So buff is going to count down from 1 to 0, and we want the previous one to be in place when we're starting the loop. There we go. So now that goes from 1 to 0, and this other one is going to be the opposite. It's going to be this. And having finished this, that should be the solution. In theory, if this works, we're done. In theory, if this works, that has just smoothed out any buffer noise that might have happened, because we are generating our new Biquad value for operating inside all of this by doing that. And we would have had to have added that anyway, because as we go through this, we're going to want the starting value and the ending value. So the interpolated value is going to be a new thing anyhow. So we just used a Biquad slot for it. And we're using exactly the same Biquad filter as we had before. But we're just going through and doing a little quick assignment, a simple math operation, which maybe it about doubles the intensity of all of this. But this is not all that demanding. And let's see how it went. Does it compile? Yes, it does. And does it run? Let's grab a sine and listen to what that sounds like. This might be loud. I think we got there. I feel like we got there. Here, we'll... Well, that's interesting. When we have a sine base... Oh, I'm filtering below the base. Fair enough. So that does sound pretty smooth. Let's go and compare it with the original Biquad and see whether we can hear noises out of that. Assuming, of course, we have it in our little list, which we don't, so let's go and get it. Here's the original Biquad. Should be about the same thing. Alrighty, we got there. This is what we were trying to fix. Here, let's make it even high Q. That is zipper noise being used as an effect. We can hear it. Those are the changes between the buffer sizes. When we're updating it buffer by buffer, it's making that happen. And the tick is the beginning and end of the sample. Actually, we don't need to do it like that. If we lower the Q a little bit, it's a crackling noise. And we can hear it because that's a bass. Ain't super loud, but that is zipper noise. And it can be louder if we move it around here. This is what we don't want, but it's a very simple algorithm. So if you're doing a fixed biquad filter, this is the form to go to, because it's slightly more CPU efficient. We're not doing as much, but it has to be fixed because under some circumstances, you're going to hear the effect. And let's compare that with the one that we just made. I maybe hear a little something in there, but this is way better behaved. I'm going to call that a win. I'm not really worried about dealing with further details because the primary issue around this, oh yeah, we have thumps too. The biquad filter will make noises when you do freaky things with it, like jump to new situations. And those clicks are not anything that you can really change because that's intrinsic to what the biquad does, but we're not hearing that crackliness anymore. And that's the case with the Q as well. It is making some funny things happen sometimes because that's the biquad filter side of it. But the zipper noise crackling aspect of it is not there anymore. And then let's fire up, I don't know, that drums again. And now we can do more fluid sweeps and things. That's what people were wanting out of the Z-plane filters. We're going to be updating the Z-plane filters to Z-plane 2 to compensate and incorporate this. Because no question about it, this is what it needs. Cool beans. We got there. Moving bandpass. Yeah, and that also feels a lot more analog-y and stuff too. Like, yeah, welcome to the real world, Chris, from Airwindows, because this is the way of doing those interpolated filters properly. I'm down. This is the new standard. Everything that uses biquads in a way that moves now gets to have this. Probably means a bunch of updates for older things, certainly the Z-plane filters. I will go through and tell people that at an appropriate time. And also, let's play with some rock and roll noise. Same deal. Or a little resonant filter, maybe? Kind of a synthy sound there. We got there. We got there. I'm going to call that a successfully completed plugin. And on the ground, on the back of that, well, let's see, fussing with my controls and stuff. I will bid you folks a good day for today. I'm going to have my work cut out for me in upcoming months because I've got a variety of things coming out. And now anybody who sees this who wanted the smooth plugins for the Z-plane stuff is going to be on me hardcore for wanting me to do that. And so I'll be following through. It might not happen instantly. It's not going to happen instantly. But yeah, anybody who is interested in the Z-plane stuff, if you wanted the no zipper noise version, coming right up. I'll be working on that probably week after week on the Monday streams. And I'm also going to be doing more music streams in Bespoke and making sure also to rest up sometimes and so on, because I can't basically beat myself into the ground doing all of this stuff. I gotta like stay healthy and so on. I'll work on that. But we just made the breakthrough that will give us the Z-plane filters with no zipper noise the way that professional synth designers do. But unlike the way professional synth designers do, it's all being implemented in long doubles, so it's extra smooth and more fluid than people normally do. So it's kind of win-win. And it's by that same token, it's going to be less CPU efficient than other people's implementations. But I guess we'll see like how nicely it adapts to everything being implemented in long doubles like I do. I have noticed one of the things, I am super into Surge as far as like big deal synthesizer implementations and being able to do lots of stuff. But there's also a synth maker going by Full Bucket, who I don't think he's open source, but his synthesizers are free to use. And he seems to like to boast of having double precision processing. So I think his stuff is not long double, but the internal parts of them are double precision. And that means it's going to be leaning more into the Airwindows sound of things than Surge does. So I have this whole balance where I'm finding different plugins, different synths for different purposes. And for some kinds of sounds, particularly simpler sounds that aren't all that sophisticated, I'm going to reach for the Full Bucket stuff and have Airwindows plugins following them up, reaching for stuff that's the synthesizers are done in double precision. And then if I need to add the extra coloring and so on, I'll do it with plugins, and maybe even plugins with stuff like the automation and so on. Like rather than doing filtering, I'll get the raw sounds and then I'll do filtering in something like Z Low Pass once I've got that updated. And then if I want to go for something that is a very complicated synthesizer, I can reach for Surge. Surge will not get exactly the same tone because all of the stuff inside it is running in float rather than double. But because all the stuff is running inside it in float, it's able to be much more CPU efficient for really complicated patches. And there's a place for everything. So yeah, it's this little spectrum. On the one side, it's Surge, and it is so CPU efficient, like processing multiplies 4 at a time and stuff, that you can do really complicated stuff. And then you got Full Bucket, and Full Bucket boasts of double precision. And then the Airwindows plugins are long double dithering to the floating point bus. So you kind of layer stuff up as you need it. And there should be plenty of fun to be had. I'll do more bespoke streams. I will certainly have another bespoke stream before the end of the week. And we'll see. Maybe it'll be the kind of fun that I can just do lots of it. We'll see. At any rate, successfully concluded plugin coding day. And on that note, we'll say goodbye to chat. Oh, Fotis was just mentioning imagine a 64-bit double precision Surge. Well, the problem with that is you could do it, but then it wouldn't run. There's a reason for everything. There's a reason why people make the choices that they do. And that is, I wouldn't be asking Surge, even as a suggestion, to start running everything on a super duper giant bus, because the amount of stuff that they have available to do, it wouldn't handle it. They're doing too much. No 64-bit Surge. It wouldn't run. I wouldn't be able to run it on my relatively powerful iMac Pro, because it would be just grinding it. Like Surge will already pull like 15% audio CPU to 20% or so, and a lot of the other synthesizers that do much less are running at more efficiency. But if I tried to build the 64-bit Surge, it would start eating like 80% and things would start crashing. There's a reason for everything. Anyways, I will talk to you folks later. Bye-bye.